All right, so we're looking back at limits. Limits is where we ended pre-calc at, okay? And that was also would have been in chapter 1 of calc, but we just kind of skipped over because we had just completed limits from there. All right, so what we're working on doing is we looked at, the concavity, we looked at points of inflection, we looked at critical points, we looked at all that different stuff, right? So we have to do the limits, and the next lesson we're going to do basically end behavior, and then what we'll be able to do is take all those 5 things and be able to graph. Remember when we graphed polynomials in college algebra? Remember that like 5-step process? You hated it? Ugh. Well, then we had the touch and turns, or cross through, you had end behavior, that type of stuff. That's what we're going to here, but it's going to be higher level stuff. It's going to be higher level polynomials and, nice fun equations to graph. Oh, of course. Of course it gets harder. You're older now. No. All right. So this is kind of where the end behavior stuff comes into play. All right, so limits at infinity looks like the end behavior of a function on an infinite interval. So if it goes on forever, think about it, we're going the whole way to the right. What number are we approaching? Is it approaching infinity? Negative infinity? Is there actually a value that we're approaching at that time? All right, that's where end behavior changes. Polynomial, we had up, down, down, up, right? Those are only 4 options because we weren't so worried about it. Now we're going to be a little more specific on the ends. All right, so definitions of limits at infinity. L is a real number, and we have a limit as it approaches infinity. Your limit is L. That means for every value there exists another value such that the absolute value minus that is less than the original value. Basically, this is saying you can have positive infinity, you can have negative infinity, and we talked about limits before. We're going to look and see what number it approaches. Okay, that's some really funky high-level math terminology, really. All right, and we talked about asymptotes before, especially horizontal asymptotes. A horizontal asymptote is anytime you're going to have a limit from both ends that hits the same spot and approaches a certain value, you can have a horizontal asymptote. So, for instance, if from the left side and the right side we're both approaching 0, all right, there might be an asymptote there at 0 because you never actually touch it. All right. And then here's just another one talking about positive rational number, any real number, then you have that theorem here. So if you look at this thing here, if I have something approaching infinity or negative infinity, and I have a number over x to a power, anytime I have something like that, that means I'm getting closer and closer to 0. Reason being, say I put it to, I don't know, say I have just x on the bottom and I have squared. Okay, if I put a 1 in, I'm going to have 1 over 1. If I put a 2 in, 1 over 4. 3 in, 1 over 9, so on. All right, so this is getting infinitely bigger on the bottom, correct? And what's those fractions? What's happening to the fractions? They're getting smaller and smaller and smaller. So what's the only number we can be approaching if we're making a fraction get smaller, smaller, and smaller? The only thing we're getting closer to is 0, okay? And that would be an infinite limit, okay? It's the same thing approaching from the left side. You're still getting closer to 0. All right, that's what that guy's saying. So let's look at this guy here. Find the limit as x approaches infinity of 5 minus 2 over x squared. So right there on the right, I already see something, right? I already see that I have it in the same format that I just talked about. Well, anytime you have a limit of 2 things like this, basically all you have to do is find the limit of each one. So we're going to have a limit as x approaches infinity of 5 minus the limit as x approaches infinity of 2 over x squared. All right, and remember with limits too, what do? We put them in. All right, if we could simplify it, you say, what if I put that number in, what happens to it? We put in a 0. Sometimes if there's a 0 on the bottom of the fraction, we had to simplify it first to get to a point where we could plug the 0 in, get a real answer. Here, Now we're talking about infinite limits, so we can't do that quite as well. But when I split this guy, is this any type of function? 5. No, it's just a constant, right? So what's the limit as x approaches infinity of 5? 5. Doesn't change. It's just 5. Now, what's the limit as x approaches infinity of 2 over x squared? Well, we just talked about the infinite limit, right? We got something over x to a power. So what would that limit be? 0, right? So what's 5 minus 0? 5. Yeah. The big thing with limits, and I think people struggle with these, the calculations are not that tough always, but the problem is you sometimes have to stop and think about what this is actually telling me. All right? Let's look at the next one. We're going to find the limit of infinity for limit as x approaches infinity of 2x minus 1 over x plus 1. All right, so looking at that right now, we got a linear function on top, right? Linear function on the bottom. Agreed? If you look at the one on the top, it's a positive x, 2x, so it's just going to keep getting bigger and bigger and bigger. So what would it be approaching? Infinity. Same thing on the bottom, right? Bigger and bigger and bigger. It's approaching infinity. So technically, this limit is infinity over infinity, right? Technically. But before, whenever we plugged in the 0, if the bottom was 0, it didn't really tell us anything. We're in the same situation here. All right? You cannot have that. Okay? You can't have infinity over infinity. So what we have to do, we have to manipulate this a little bit to get to a point where we can get a real answer. All right? So I'm going to go ahead and just split this thing up again. Say the limit of as x approaches infinity of 2x minus 1 over the limit of x approaches infinity of x plus 1. All right? Now, we need to get some x's out of here somehow. The quickest things I see is let's divide the top and bottom both by x. Okay? That'll get us a chance to cancel some x's, hopefully. And divide by x, and divide by x. Now, when I divide the top one by x, I'm going to write out some extra steps here. It's going to look a little bit long, but I'm going to limit of, I'd have 2x over x minus the limit of 1 over x, just like we did in that last problem, right? On the bottom, the limit of x over x minus the limit of 1 over x. Now, x's are gone. Boom, boom. So now, I just have a constant. What's the limit as it approaches 2? 2, right? It approaches infinity and the value is 2. On the bottom, this is just the limit of 1 now. So that's pretty simple. Now, on the right side, because I divided by that x, it gave me something over x, right? It would be the first power, but does it still fit this format from here? Yeah, it fits that format. It fits the format of limit of x approaches infinity of something over x to a power. This would be over x to the first, but it still works, so 0 and 0. So what are we actually approaching? 2. 2 minus 1 over 1 minus 0. So we'll be approaching 2. You guys all right with that so far? All right. All right, next one. I'm going to put 3 limits up here. They're going to be very, very similar. All right. I'm going to do the first one. Let you guys try the second one, and probably do the third one together. Sound good? All right, so first one. the limit as x approaches infinity, 2x plus 5 over 3x squared plus 1. All right, now looking at this, what I want to try to do, just kind of something to have in your mind, whatever the x value is on the bottom, divide that. So I have an x squared on the bottom here. Okay, so I'm going to divide the top and bottom both by x squared. Okay, so I would have 2x over x squared plus 5 over x squared over 3x squared over x squared plus 1 over x squared. And again, I'm not writing out limit every single time for every single value. I hope you know that that's what it is. You guys all right with that? It gets old writing limit as x approaches infinity. All right, so up top, simplify a little bit. I'm going to have, 2 over x plus 5 over x squared over 3 plus 1 over x squared. So 3 out of the 4 are in the form something over x, correct? So I would actually have, on this one, I'm going to have 0 plus 0 over 3 plus 0. So my answer would be 0. So my limit in this case would be 0. You okay? Are you, The reason I did these three, we're going to do one more here together real quick. Very, very similar, but just notice the power of your axis. Okay? The top is less. The top and bottom are the same. Now we're going to do this. Limit as x approaches infinity of 2x to the third plus 5 over 3x squared plus 1. Okay? Now this one, my top is a higher power than the bottom, right? So I'm going to go ahead and just kind of flash forward a little bit because I'm going to end up with this. 2x plus 5 over x squared over 3 plus 1 over x squared. Okay, so now where this gets weird at is this is 0, this is 0, this is 3. Right? No different there. But now I have a 2x. Right? 2x is a linear function. Agreed? Is it a positive linear function? Yeah. So as we're getting closer to infinity, that is also increasing the whole time, right? Because I'm putting different variables for x in, it's continually getting bigger and bigger and bigger. So what would 2x be approaching? Infinity. So technically, we would have this. Okay? And it would technically be infinity over 3 was your answer. But does that even sound remotely possible? Yeah, that's not a number. All right? It's an idea over a number, right? Infinity is really not a number. It's more of an idea. So in this case, it does not exist. Okay? Anytime you have something with infinity in it like that, it does not exist. It just means there's no defined limit. So it'll still go on forever. It'll go on. Would approach infinity, but again, infinity is not an exact value. So we're looking at the end of a function, for instance, right? So as maybe my function goes like this, and I could say it's approaching 3, or we'll say 2. That's just where I drew it. So it says approaching 2. I know where this function is going to be at. Okay? If it's approaching infinity, say I know everything to this point. If it's approaching infinity, it could be one here, 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 here. You see what I mean? So there's nothing really defined to get an exact idea of where that function is going to be finishing out after you get past the points that you can define. Okay? Guidelines for finding the limits at positive and negative infinity of rational numbers. So the degree of a numerator is less than the degree of the denominator, then the limit of the rational function is 0. Degree of the numerator is equal to that, it's going to be the leading coefficient. The degree of the numerator is greater than the degree of the denominator, and the limit of the rational function does not exist. And that was those three that we just did. Just showed that. All right? Questions? Functions with two horizontal asymptotes. I think that'd be a good place to start tomorrow. I think it's a little tougher there. I will not put